In this lesson, what we're going to do is work on estimating with scientific notation. This isn't you won't use this one too often, but I need to show you how to do it for the different practice problems in your lessons. So say we have all this and it says to estimate. So it doesn't want you to put it in a calculator, nothing, don't do it by hand. What we're going to do is estimate. Well, what we're going to do is estimate all these to, let's look at 16 for example. Look at number 16. How can we estimate that in scientific notation? Well, you look at, okay, does this round to, you look at the, I guess the ones place. Would the 1 round to 2, or would it round down? Well, we already know that if it's 5 and up, then you round up. And if you had, or I can put it this way, 5 through 9, you would round up. And 0 through 4, you would round down. Okay? So here's how we write it. So since this is the second number is between 5 and 9, we are going to round up. So what we're going to say is 2 times 10 to the first. That is how we would round the number 16. So we're going to write that over here. 2 times 10 to the first. You could just say times 10, but so let's look at the next one, 5,280. Okay, we look at the ones place, and then we look at the number after. Would this round up to 6,000, or would it stay down at 5,000? Well, 280 clearly would round to 5,000. So what we would say is 5 times 10 to the 1, 2, 3 power. Once again, because we are moving the decimal to 3 to the left, we move the decimal 3 to the right for the tens power on the number line. So we would say 5 times 10 cubed 3 times, since there's 3 of them. Just kind of monotonous, not really difficult, just monotonous. So we've done those 3, now we got to do 12. All right, 12, and that's going to round to 1 times 10 to the first, because 12 would round to 10. And then we move the decimal 1 time, so we got the 1 there. So we're going to move this over. 12 times 10 to the first. 12 times 10 to the first. 3 times. So now we've got it all out there. Now we just got to put it all together. So when we put it all together, what I'm going to do is multiply all the whole numbers. The 2, 5, 5, 5, 12, 12. Sorry, this would be 1 times 10 to the first. Caught my error. A good thing, because otherwise it would have been confusing. Now we're going to multiply what we got here. And so what we're going to have is 2 times 5, that's 10, times 5, 50 times 5 is 250. So we're left with 250 times 10 to the, okay, we got 1, plus 3 is 4, plus 3 is 7, plus 3, 10, 11, 12, 13. So times 10 to the 13th power. Remember, if exponents are being multiplied, you add their sum. So we're here. Now this is not simplified yet. Like we had, because 250 can be estimated and simplified a little further. Does 250 round up, or does it round down? Well, the 5 is straight in the middle, so therefore it rounds up to a 3 times 10. Let's see how many times we move the decimal. Twice to the left, therefore twice to the right. And you could say times 10 to the 13th is still there. These are common terms. So we can add the 13 and 2 together, the exponents, and be left with 3 times 10 to the 15th. And that would be what that is estimated. So it's a little monotonous. You just got to understand estimating up or down. But you look at the ones place and then estimate from there. Let's look at another example. Example 2. Okay, now we got a numerator and denominator. Isolate each one. Does 3,728 round up or down? Well, 3,700 would round up, so that'd be 4 times 10 to the, we move the decimal 1, 2, 3 spots, so 10 to the third. Okay, this one, it already has a power of 10. So this one, first of all, we look at it, would 470,000 round up or down? Well, that would round up to 5 times, let's see how many times we move the decimal. 1, 2, 3, 4, 5. So we're moving the decimal 5 to the left. Therefore here, we would go 5 to the right, aka add 5 to negative 14. So 5 plus negative 14 is 10 to the negative 9th. 10 to the negative 9th. Do the same thing here. This rounds up to 3. Because 278,000. Move the decimal 1, 2, 3, 4, 5. So you add 5 to 10. Power of 10. Here, move the, okay, so here, same thing. Look at the 713. You just look at the numbers after the 0. 713, well, that would round into 7. It's not going to go up. But how many times do we move the decimal? 1, 2, 3, 4 to the right. So therefore here, we're going to move 4 to the left, aka subtract 4. Negative 5 minus 4 is negative 9. And then what we do from here is we're going to multiply the top whole numbers. So 4 times 5 is 20. Add these together. 3 and negative 9 would be 10 to the negative 6th. Then on the bottom we would have 3 times 7, 21, times 5 and negative 9 added together would be negative 4. Don't need the parentheses. From this point, let's look at the 20 over 21. Well, that rounds to, like if I did it in a calculator, around like 0.9 something. So what we can just do is say 1. We can just say 1. Because 20 over 21 is estimated to be 1 times 10. Remember, if we move this to the top in the numerator, it becomes 10 to the positive 4th. So 4 plus negative 6, negative 2, 1 times 10 negative squared would be your answer. And we'll look at one more just real quick, just because I know this one could trip us up. And I'll go through the estimating part really quick. We got 0.04186765. And this is example 42.3. And it's times 10 to the negative 14th. 41725. Stupid. Times 10 to the 43rd. 9764 times 10 to the negative 23rd. Okay. I'm going to go really fast in the estimating of this. If you need practice on that, rewind the video and look at those. Got to align this thing. Okay, so I'm going to estimate this. Well, this would estimate to 4 times, move decimal twice to the right, so subtract 2, 4 times 10 to the negative 16th. This would round to 4 times 10, 1, 2, 3, 4. So 4 to the left, I just got to see it, 4 to the right, so add 4, 10 to the 47th, over, that's a 9, I believe, okay. So if you have a 9,764, if you have that, what you're going to do, okay, let's say we move the decimal 3 times. 1, 2, 3, so we're moving 3 to the left. However, if it becomes 10,000, so we say 1, that would actually mean you would need 1 more. So you would actually call it 1 more, because if you had 10,000, you would have 1, 2, 3, 4 spots. So what we're actually going to say is 4 to the left. So when we add 4 to the right here, that's like saying plus 4, that gives us times 10 to the 19th power. So that's how you do it if it's funky like that. You just add an extra 1. And so now we get 4 times 4 is 16 times 10 to the, those would be 31 over 1 times 10 to the 19th. So now so now we're here. 16 over 1, well, that's just 16. I'm going to get to that part in a second. We're going to look at that in a second. I'm going to go ahead and convert this up here. Negative 19, that's a weird 19. 31 minus 19, that would be 12. So 16 times 10 to the 12th is where we're at. Oh, sorry. This should have been a negative. My bad. This should have been a negative. That would make this a negative. This actually converted positive. Just caught my error there. Just caught my error. So that would actually be 50. 16 times 10 to 50. My bad. That's on me, team. That's on me. So here, we can still estimate this 16. We want to make it estimated. So we move the decimal once. This estimates to a 2, because it would be 20. And then it moves once to the left, so it moves once to the right here. So 2 times 10 to the 51st would actually be our answer. So that problem just kind of gave some, different looks at it. But anyways, that should cover estimation and how to estimate scientific notation.